Intercept form of quadratics. Form number 3. Intercept form. I told you a couple days ago, mathematicians are smart, not so creative though. And we typically, and I say we, like I'm one of the people who did it, we typically name our equations based off of what those equations do. Vertex form of a quadratic? Yeah, gives you the vertex form, or it gives you the vertex, excuse me. Intercept form of a quadratic? It gives you the intercepts, the x-intercepts to be specific. You guys remember factoring from Algebra 1? Do you remember factoring? I'm not saying do you remember how, I just remember saying do you remember the term and realize that, you know, you take a polynomial, which is usually a quadratic, and you could split it into two sets of parentheses, right? Factoring, yeah, that's what intercept form is. Intercept form is the quadratic in factored form. It shows you the two factors. So we put an A on the front, which represents the same thing it represented in vertex form, the same thing it represented in standard form. That A on the front shows you if it points up or points down. Positive people smile, negative people frown. That A on the front will also describe to you how the parabola looks. Does it look narrow? Does it look wide? It's the same exact A thing. It does the same exact job. And that's why I like transformation so much. They always do the same thing. What about the letters P and Q, though? P and Q are the places where your graph crosses the x-axis. Intercepts, the x-intercepts. You know what I've been asking you basically every day for this entire year is, what makes the inside equal 0? Well, that is still going to be the question. What makes the inside equal 0? The only difference is now there's two different numbers. There are two different numbers that make the insides equal 0. And those two numbers are the places where a graph crosses the x-axis. So the graph crosses the x-axis at x equals p and x equals q. Boink. And you will notice that that uncovered something in my sentence there, and it uncovered something on the picture. When you're on the x-axis, y equals 0. So if you cross at x equals p, the coordinates for that are p comma 0. Copy the homework at a later point in time. We're doing notes now. You can copy the homework at home. And q comma 0, well, that's just telling you it crosses at q on the x-axis. And you can see that's why I put those coordinates on the picture over there by those big blue dots. Those are called the zeros, or the x-intercepts, or the solutions. All of those words mean the same thing. Zeros, x-intercepts, solutions. Okay, now axis of symmetry. The axis of symmetry always cuts the parabola in half. So if I knew the two places where my graph crosses the x-axis, how could I find the axis of symmetry? Any ideas? How about this? Let's pretend my graph crosses the x-axis at the number 0 and the number 10. Where is my axis of symmetry? If I can cross at 0 and 10, where is the axis of symmetry? 5. How did you get that number, though? Halfway. Yeah. If you can see the two places where your graph crosses the x-axis, you literally could just go halfway in between them. Do you know what a good way of describing that halfway number is? Average. The average of two numbers is always halfway between them. The average of 0 and 10 is 0 plus 10, 10, divided by 2, 5. That's why the axis of symmetry gets the equation. Oh, I didn't show you yet. I said average them. The axis of symmetry gets the equation p plus q over 2. Now, I know a lot got uncovered, so I'll wait for you to get it filled in. And I'm just going to keep reiterating what it says. The axis of symmetry is halfway between the zeros. You could count. You're welcome to. But that only works when you have a graph. So if you didn't have a graph, how would you do it? You would average the two numbers. Take the two zeros, whatever they are, the two x-intercepts, add them together, divide by 2. For example, if one's at -1, and 1 is at 9. Negative 1 plus 9, 8, divided by 2, 4. Axis of symmetry would be at x equals 4. It always, always works. Notice the equation, the form of the equation looks like this is always a minus and this is always a minus. Of course, P or Q or both could be a negative number. So you'd have minus and negative, which creates a plus. But what I want you to really notice is this. Minus P minus Q, positive P positive Q. It's the opposite sign, just like when you're trying to find the vertex. It's the opposite sign. And that's because inside changes are opposite. That's why that's happening. Parabolas never change, just the way we write them does. Look, the axis of symmetry cuts the graph in half still. That means it must go through the vertex. That is never going to change. And when you know the x value of the axis of symmetry, you know the x value of the vertex, because the axis of symmetry goes through the vertex. So that means my vertex would be P plus Q over 2, comma. Well, if I know the x value for the vertex, how do I find the y value? Yeah, let's plug it in. You just plug it in. So you find the y value of the vertex by plugging in the axis of symmetry, just like you had to do for standard form. Yes, I know it's a different equation, but the process is still going to be the same. You're going to find the x value of the vertex, which means the axis of symmetry. And then once you know that number, you will plug it back in to get your y value of your vertex. And I've already talked about A. The A value does all the same things that it did in standard form and all the same things it did in vertex form. It doesn't say and vertex form, but it is. It tells you, does it point up, point down? It tells you, is it wide or is it skinnier than normal? And that's all there is to know about intercept form. Is intercept form difficult? No. Is standard form difficult? No. Is vertex form difficult? No. Is keeping all the information straight, because I've now taught you 3 different forms and they all have their own rules? Yeah, probably a little bit difficult. And that's why I created the parabola cheat sheet for you to help you study. And that's why when we practice and do homework, I will continue to show you all 3 forms, because you need to be able to keep them straight. So how do you recognize vertex form? Vertex form is recognizable because it'll have a single set of parentheses squared. How do you recognize standard form? Standard form has no parentheses. How do you recognize intercept form? 2 sets of parentheses. It'll always have 2 sets of parentheses. So 1 set of parentheses squared, vertex. No parentheses, standard. 2 sets of parentheses, intercept. That's how it is. And I just need you guys to memorize that. I need you to know, what form am I looking at? And then once you know what form you're looking at, I'm asking you to memorize how to find the vertex and axis of symmetry of all 3 forms. And they all have their own ways. And then maybe a couple other things, like standard form would be great if you knew how to instantly find the y-intercept. And it would be great if you knew what A does for, well, all 3 forms. Okay. That is it for that. Let's practice. It says find the x-intercepts, the vertex, axis of symmetry for this function, and then we're going to graph it. This is basically what your homework looks like. Your homework, if I remember correctly, is 2 intercept forms, because that's what we're learning today, 1 vertex form, and 1 standard form. That's it. I'm asking you to graph 4 things for homework, but I'm asking for several pieces of information along the way. I'm asking for you to tell me the vertex, the axis of symmetry, sometimes the y-intercept. Just, you'll see, but it's really only 4 questions. Wednesday, because we will be practicing it on Tuesday. Yeah. This way you can work out all the bugs, and it's a long weekend. You're probably going to forget some stuff. But yeah, so we'll practice on Tuesday. It would be great if you had a lot of the homework done before then, or maybe all the homework done before then. That'd be fantastic, but you don't have to. It's not due till Wednesday. 1/2, eek, a fraction. Oh my gosh. Yeah. A couple years ago, I honestly, seriously thought about making my kids' Halloween costumes fractions. And me and my wife, we always do a family thing. We always do a themed thing, and I was like, we should all be fractions this year. And people were like, why? I'm like, because fractions are scary. That's why. People are scared of fractions. And it was going to be fun, too, because I was like, you know, I could be like 4/8, and my wife could be 3/6, and then both our kids could be 1/2. Get it? Because they're small versions of us. Come on, tell me that's not fun. I'm going to do it one of these years. If they get old enough, and hopefully they like math as much as me, we're going to do it. It's going to be epic. Okay, anyway, so scary function here. 1/2 in front, and I have x plus 4 and an x minus 2. It says, what are some things we know about this graph? Just like last time, what are some things we know? Here's what we know. The number on the front is positive, so it points up. We know that. Oh, it's red. Well, whatever. We're already doing it. Points up. We know that because the number in front is positive. But not only is that number positive, that number is a 1/2. So what that means is it's going to appear to be wider than a standard parabola. So you can say it looks a little wide. Good. Now, just by looking at the equation, we also know the x-intercepts. But that's the next question. What are the x-intercepts? The x-intercepts are the two values, the two numbers for x that make the insides equal 0. So what would make this equal 0? -4. So this is going to happen at -4, 0, because remember, when you're on the x-axis, which is what intercept means, y is 0. And what would make this equal 0? +2. So we can go ahead and put those two values on our graph. -4, +2. That is where our graph crosses the x-axis. Now we do have the luxury of a grid, so we can legitimately just count. See how far apart those two dots are and only go halfway, like Lewis said. So let's count from -4 to +2. 1, 2, 3, 4, 5, 6. So halfway would be 3. 1, 2, 3. There it is, right there. The axis of symmetry happens at x equals -1. That's halfway. But what if you didn't have a graph? He said, thinking about his test, wink, wink, nudge, nudge. What if you didn't have a graph? What would you do? You would use the formula for axis of symmetry, x equals p plus q over 2. And those two numbers, p and q, are your x-intercepts. They're the places where the graph crosses the x-axis. So you go, okay, -4 plus 2 divided by 2. Well, -4 plus 2 is -2. And -2 divided by 2 is -1. Oh yeah, there it is, x equals -1. Okay. Just confirming that it works, in case you don't have a graph. Or you don't want to make a graph, because that's not what you had to do on the test. Oops, I said one of my test questions. Okay, so let's see. What are we going to do next? Well, we can't graph this thing without a vertex, can we? What we do know, though, is that the vertex has to be somewhere on that axis of symmetry. That means that vertex is going to be -1 comma something. -1 comma something. And in order to find that y, just like in standard form, we are going to have to plug in x equals -1. So let's see what f of -1 is. All right, well, there was a 1/2 on the front. And then in these parentheses, I had a +4 and a -2, correct? Like that. And I am dropping in x equals -1. Okay, let's see. Y is 1/2. -1 plus 4 is 3. -1 minus 2, -3. That is 1/2 of -9. Oh man, it's going to be a decimal. That's okay. It's not a big deal. What's half of 9? Oh, you have a question? Yeah, what's up? Oh, it didn't matter. Just because it's easier. You know what we don't do, though? We don't distribute, quote unquote, that 1/2 to both of them. You don't ever do that. So that's another reason why I multiply the two 3's together, because it stops a student from trying to distribute, quote unquote. The only time you distribute is when things are separated. if I have a number on the outside of parentheses and on the inside of the parentheses there's pluses and minuses. If there's no pluses and minuses, you just multiply straight across. So I just went ahead and did the 3 and negative 3 because it'll stop that mistake from happening. Half of 9, anybody? We know it? 4.5, but it's negative, so we have negative 4.5. Oh no, a decimal. It's okay, it's a pretty decimal. Negative 4.5. No biggie, no biggie. That's halfway between negative 4 and negative 5, so there you go, right there. And just connect the dots. Wee. There you go. I'm not proud of that parabola, but hey, it's okay. It's just a sketch. Scroll back down so everybody can see what we did. And before we go to the other examples, I would like you to ask me some questions if you have them. Let's get them out there. Air them out. Let's hear them. Yes, sir. You know, it doesn't actually matter which one is P and which one is Q. Just by definition, we just write P before Q because alphabetics. But honestly, it doesn't matter. Yeah, I'll never be like, ha, got you. You said that was P when it was Q. No, it doesn't matter. It doesn't matter one little bit. And the reason why is because multiplication doesn't care about the order. So the order that you wrote the two parentheses can be switched, and it doesn't change anything. Even when you add them. If you say 2 plus negative 4, it's the same as saying 2 minus 4. Yep, so it will not make a difference, I promise you. So anytime, any kind of test questions, like for IB, from my IB class, they actually have test questions that say, what are P and Q? The answer key shows it both ways. Because they could have said P equals negative 4, Q equals 2, and they go, and in parentheses they write, or P equals 2, Q equals negative 4, because it actually doesn't matter. But I won't do that to you guys. What I would do for you is I'd be like, hey, where are the x-intercepts? And you would say negative 4, 0, 2, 0. Any other questions? It's a good question. Come on, guys, hit me. Folks at home, we good? Scares me a little bit. All right, well, I mean, I won't force you. Let's see what we got. Let's go to the next question after the board catches up with me. Okay. Well, at least there's no fractions on this one, right? The exact same instructions, though. Not a thing has changed except for the equation. I see that front number's a 2. That tells me some stuff. Well, it's positive. That tells me it points up. And that number 2 is bigger than 1. So if 1/2 made it look wide, number bigger than 1, going to make it look a little skinny. Let's say it looks narrow. That's better academic vocabulary. Looks narrow. It's actually not narrow, it's tall, but whatever. The x-intercepts are always going to be the x values that make the insides of my parentheses equal 0. That literally means you just use the opposite symbol. So my two x-intercepts as coordinates would be negative 1, 0 and 3, 0. So let's put your dots on your graph. So once again, you have a graph, which means you could literally just count halfway between the two things and drop your x-intercept, your axis of symmetry. Let's go to it. Count between it. 1, 2, 3, 4. Oh, they're 4 apart. So halfway is only 2 apart. So I start at the first blue dot, go down 2. It puts me at x equals positive 1. There we go. But what if you didn't have a graph? There's a formula. When you're doing your homework, and I say, what's the axis of symmetry? If you get there by counting instead of by using the formula, okay. I'm just going to strongly suggest you know how to use the formula. Strongly suggest, he said, with his eyebrows raised up real high. Oh, remember, mid-chapter test is the end of next week. Let's plug these numbers in. Negative 1 plus 3 divided by 2. Negative 1 plus 3 is 2, and 2 divided by 2 is, hey, look, x equals 1. Yeah, we know. just confirming that the formula works. Since this thing points up, I know that my vertex is going to be somewhere below my x-intercepts. I know that. But I don't know exactly where. So I need to find that y value, and I know that the axis of symmetry goes to the vertex, which means it shares an x value with the vertex. So my vertex is at 1 comma something. And we have to find that something by plugging in x equals 1. And everywhere there was an x, we drop in a 1. Yay, easy math. 1 plus 1, 2. 1 minus 3, negative 2. And 2 times 2 is 4, times 2 a third time is 8. But it's negative. There you go, negative 8. 1 comma negative 8 is our vertex. Woo, that's pretty far down, isn't it? That's okay, because we thought this thing was going to look narrow. Yeah, it's tall. It's a tall graph. And you just draw your parabola through your zeros. There we go. That one's better than the first parabola I drew. The first one was a little drunk. This one looks good. Ta-da! I mean, again, I don't think that this is difficult. I think the amount of material, well, that's a lot. It's a lot to remember. And that's why I give you practice days, and that's why I'm telling you please study. That's why I gave you the cheat sheet. It's a lot of material to memorize, but none of it's difficult, in my opinion. Biggest pain in the butt for graphing? Standard form. I think that's the biggest pain in the butt for graphing. Graphing vertex form, graphing intercept form, pretty darn easy. Questions, comments, and concerns before we move on to our last example for the day? No? All right. Okay. Hopefully this one points down, because I've had 2 that point up, and okay, good. All right, good. Eek, another fraction. Oh my goodness, it's negative. Ah! No big deal. I got you covered. No big deal, okay? What do we know? Well, front is negative, so I know points down, because negative people frown. And that 1/4 on the front, well, 1/2 made it look wide. 1/4 is going to make it look even more wide. So this looks pretty darn wide. So we'll be expecting a wide parabola this time. X-intercepts, well, you just use the opposite symbol of what's in the parentheses, basically, because that's what makes the insides equal 0. So my first x-intercept is at negative 5 comma 0, and the other one will be at 3 comma 0. Those guys are spread out. Spread out. For the third and final time, you have a graph. So you can just count halfway between these objects. And that's where your axis of symmetry will be. So let's see how far apart they are. 1, 2, 3, 4, 5, 6, 7, 8. So go halfway through, that would be 4. 1, 2, 3, 4, right there. Axis of symmetry at x equals negative 1. But just to prove the point, going to fill out that axis of symmetry equation again. You notice how every time I do this, I write the equation? I do it every single time for intercept form. I do it every single time for standard form too. If you do it every single time, you will not forget those equations. If you just skip directly to plugging in numbers, well, you're probably going to forget the equations, to be honest with you. What do we got? Negative 5 plus 3 divided by 2. Negative 5 plus 3. And remember, you're going to have a calculator for the test, scientific or for function. Don't panic about your negatives and stuff like that. But negative 5 plus 3 is negative 2. And negative 2 divided by 2 is negative 1. Yes, we know. X equals negative 1. We already had it on there. Just demonstrating that the formula works. Just in case there's not a graph for a question like this at some point in your future, I'll just say. Last but not least, vertex. We know what the axis of symmetry is. That means we know the x value of the vertex. That x value of that vertex must be negative 1. Since this thing points down, I expect my vertex to be above the x-axis. See, it's good to know things like that. That way, if the graph doesn't match what you already knew had to be true, you know that you probably just made a math error in your calculations. You just go check your minus signs. It's probably a negative sign got goofy somewhere. Maybe you fat fingered a calculator. I don't know. Let's plug in x equals negative 1. F of, there was a negative 1/4 on the front. Then there was a x plus 5 and an x minus 3. We are dropping in a negative 1. Negative 1 plus 5, 4. Negative 1 minus 3, negative 4. And trust me when I say you could do this without a calculator. I'm multiplying 3 numbers. 2 of them are negative. What does that tell you about the result? It means it'll be positive. Because I'm multiplying 2 negatives, yes, also a positive, but because I'm multiplying 2 negatives, I know my result will be positive. So the negative signs basically have canceled each other out. Don't have to worry about those. And what happens when you multiply 1/4 and 4? What do you get? What's 1/4 of 4? Yeah, it's 1. So this says 1 times 4. There you go. You don't need a calculator. Negative 1 comma 4. Of course, you would have a calculator, so I'm not too worried about it. I'm just letting you know that you don't need one. Negative 1 comma 4, and we will connect our dots. Where is that bad boy? Right there. Yeah, that is definitely going to be a wide parabola. Look at that thing. There it is. Can you see it, Jay Sean? I see you having to look over the shield a lot. Sorry. But that is it for intercept form. I mean, again, I'm not trying to be condescending. I think it's pretty easy. Yes, sir.
How did you get y equals 4?
How did I get y equals 4 at the bottom?
Yeah.
Well, are you comfortable with the 2 negatives making a positive? Because it was a negative 1/4, and to the far right there was a negative 4.
Well, what I did was I multiplied 4 and negative 4.
Right, and you got negative 16. So 4 times negative 4 is negative 16.
Never mind.
You sure? Okay. Yeah, so I couldn't, and that's what I did when Lewis asked me in the first one. I did do that. So 4 times negative 4 would have given me the negative 16. And I would have had the negative 1/4 times negative 16. And I would have said, okay, well, the 2 negatives cancel. And then you could say, what is 1/4 of 16? And get 4. Yeah. Yes, sir? Ah, so you've noticed that pattern, huh? Yeah, so whenever you plug in the axis of symmetry, you're going to end up with the same number in the parentheses. Now, that doesn't mean they have to have the same symbol, but they will have the same numeric value. Yeah, it happens every single time. The reason why is because that axis of symmetry is landing halfway between the 2 x-intercepts. So you'll end up with usually a positive distance on one side and a negative distance on the other. But yes, you know, no one's ever asked me that either. But yeah, it happens every single time because it's distance from the axis of symmetry. That's literally what that represents. See, one of them was 4 and one of them was negative 4. And if you go to the axis of symmetry, one of the zeros was to the left 4 and the other one was to the right 4. But yeah, they'll always end up being the same number. And usually one positive, one negative, but I don't want you to guarantee that. They don't have to have the same different symbols. Okay. And that's it. That is it for intercept form. So we'll call the video there.